Assalamu alaikum, students, and welcome back to this channel. And today we are talking on chapter number 8. And in chapter number 8, from detail and detail, we are today talking about characters and strings. And today's lecture is more about functions, how to deal with functions related to characters and strings or arrays and all that stuff. And these are the total today's agenda over there. Of course, this is a very long chapter again, from the slides point of view, almost like 60 plus slides over there. But just to keep things straight over there, I'm just going to cover like 3 or 4 parts over there in this first part, and then maybe the next part will be covering the rest of the remaining items that are 5, 6, 7, 8, which are related to other library functions. And for this purpose, I have the book also here in front of me, the chapter number 8, the characters and string over there, as you can see. And it has almost like 8 point up till 8.10 over there. And hopefully in this first part, I'm going to discuss up till 8.4. In fact, 8.4.1, I will be discussing in detail, and also 8.4.2, which is actually a function to convert a string into a double digit or a double data type or a long data type. Now, how you're going to convert a string, actually, that's actually the question over there. But before that, we have to first of all see that what is a string and what is a character inside your C language. For that purpose, I have the book also in front of me, and just to aid you the understanding, because now the chapters are becoming a little bit more difficult in terms of functions, and you have to a little bit memorize these functions as well, because whenever you are working on a code where you have to actually deal with some strings or some characters over there, then you need to find out specifically when you are going to take an input from the user. Supposedly you are asking a user to enter your name, and if supposedly he does not enter his or her name, but if it actually enters some digit over there, so you have to first of all find out that the number entered is correct. Or supposedly you are taking a password from a user, and sometimes all of you have a Gmail password or a Google password or maybe an Instagram or a Facebook password. So every time there is a condition required over there that the password should contain one alphabet, one digit, one underscore, or one the @ symbol, or some other symbols to be added over there, or the length of the password has to be. All this has to be done at the programming level. So you have to find out that your string, because that is actually going to be a string over there, which is going to be entered as a password. So that has to be checked how it has an alphabet, it has an integer, or sorry, it has a digit over there, it has a symbol over there, it has some punctuation marks being added over there, or they are allowed or not allowed, because some other different companies, they have it over there, because they're adding punctuation marks, adding exclamation marks, adding equal to, plus sign, or all these symbols over there actually make it very easy for the server to actually process it, but it makes it very difficult for any hacker to actually hack your password, because the number of possible options becomes decreased when you are doing that one. So here I have it over there, and just to aid you, I have this w3schools.com website also, and I've clicked this C tutorial over there. And if you scroll down below over there, you have over here these C reference libraries. You have already used this stdio.h, stdlibrary.h. We will hopefully be using in chapter number 9 in detail. But here today we are going to talk about the Ctype.h, and in the next part I'm also going to talk about the string.h. And if you remember in the lab also, or in the theory also, we have used this math.h in extensive detail. Sadly, the time.h is not going to be used extensively in this course, but if you people require, maybe I can do one separate part for this part, and we can discuss the functions available which are inside the time.h, because C library can handle the timing functions also. So without any delay further, if you're talking about the std library, just to give you a peek overview, we have talked about this a little bit in detail, if you remember it over there. But again, this will be discussed, the remaining one of them, supposedly this atoll and all these sums. These are going to be representing the libraries which are inside the standard library of a C over there. But we will discuss them in detail, most probably in the next lecture or in the next chapter actually over there. Today, our main starting point is actually the string.h library, or the Ctype.h library, which has all these functions over there, and these are quite explanatory over there. For example, you can see over there, these are all the functions, and I will go one by one through all of these, and then I will go on towards the Visual Studio, making all these codes also here in front of you for this part. So if you see over there, the first function inside the Ctype.h over here is isalnum. Now, what is this one? This is an alphanumeric number. So this is actually a function, and it is going to give you either 1 or 0, or which means that if it's going to be 0, this means that it's not a alphanumeric number or alphanumeric character. So all these functions which you are seeing over there, they are all going to take a character. They are not string functions. That's why they are called as C type functions or character type. The C over here stands for the character type over there. So modifying the characters over there. So here you can convert it one by one into the character over there, or check it that it is of course there is a question over there, it's making it into a question. So this function, if I just show you, just to give you an idea what this means over there, is this, that you have this is alphanumeric. So it's actually going to check the function. Supposing you have a character C equal to A, and here in the if statement you call this function. Of course this function has to be called after including the Ctype.h library, and I will just show you this one in practical on the Visual Studio Code just now. So if you're doing this is alphanumeric in C over there, then if this statement comes true, which means it's going to give an output as 1 or something non-zero number, then this means that the printf statement is going to be run, and this is brackets, sorry, percentage specifier C is alphanumeric, which means that C is alphanumeric because C is equal to, and remember, characters are always stored as single quotes over there. Now, just to go on back on the Visual Studio over here, before I can go on, I have a small file over there which is called as string.c. Now, one thing very, very important over there. Now, I have over here, if you can see very closely over there, I have added over here, I have not added Ctype.h over here. I will do that one in the next file over there. I have stdio.h, I have stdlibrary.h. I have just added it by default over there. I still don't need this one at present, so I can just take it off from here as well. Over here, I have character, pointer, string 1 equal to I am University of Engineering and Technology student. And then I have character, string 2, array. Now these two are practically having the same thing, which means they are storing a string. But the way to store is different. Now, this is something very, very important. If you see this one, what is this? This is an array of how much length? You can count it from this I space, A, M space. You can see over there, this is character 39. So this is actually the length of this array is 39. You can, the Visual Studio Code is automatically give me the count of it. That's 39 over there. So it's actually an array. The name is string2, and the array is of character type over there. And it has 39 size over there. So this means from 0 to 38 is going to be there. And of course, the last one is going to be the null terminating. That is actually the over there. So this is going to be the character array over there. Now, if you talk about this thing, now what is this? You all know from chapter number 7 that this asterisk sign makes it into a pointer. So what I'm doing over there, I am having a character pointer, which is named at string 1 equal to a string, and this string is going to be stored somewhere inside the memory, because when this program will be run by the compiler, this string will go inside the memory and stored somewhere in some block, and that block will be having some address. That address will be copied inside string 1, but only the address of the first alphabet or the first character over there. It's a string stored successively inside the memory. Successively means that supposedly if this is at memory location, supposedly 20, this space is going to be at 21, this is going to be at 22, then this is going to be at 23, then space is going to be at 24, and so on, so on, so on, so on. So this character is also just like stored as an array, but here it is being pointed as a pointer to a memory location over there. So these are two ways of storing a string. One is using a character array. The other one is using a pointer to a string stored inside the memory. And you can use both of them inside these functions over there. But the function which I'm just talking about you is alphanumeric or something like that. They use the character C, which has only single quotes. Remember, when you have a string, you have to use double quotes, even if you are using inside a array, or even if you are using inside the pointer or to a string which is stored inside the memory. And if you are having a single character or a single alphanumeric or a digit number over there, then this has to be inside single quotes. So this is going to be C. And remember one thing, whenever this C is going to be stored inside the memory, you can even make it C++. Now, you may be arguing over there, what will C++ do? This is not an integer. Now, remember, I told you, and you have got through inside your other courses as well, that C is stored inside the memory as an ASCII number. So A has an ASCII number of, I guess, 65. So it will be stored inside the memory as 65 inside 1 byte over there. So when you are doing C++, the C++ is going to make it 65 plus 1, 66. So when now you are going to call this, like over here you can see I have done printf, string1 text is, and here I am using %s and I'm writing string1. And here I am writing string2 text is %s string2. Both are going to be giving me the exact same answer. This means these two statements over there. I can have the two statements as same over there. Let me just have the same statements over there so that they are not different. I am a BSc artificial intelligence. I am doing BSc artificial intelligence over there. So these two statements are going to print these two strings, which are exactly the same. So this is string1 text is %s because this is a string. Remember, if it was a character, then it will only print one character from this string, whichever it is pointing out. And this is also a pointer. This is a array. And the last one is character is here. This is %c. So it will be only printing one character, that is A over here. So this is going to be character is C over here. So let's just run it and see what is the answer. And when this runs over there, because it's taking first time, so you can see string1 text is I am doing BSc intelligence, artificial intelligence, and then I have string2 text I am doing BSc artificial intelligence, and then character is B. You stored A, but since you did C++, then you have B. Now you may arguing it that what will be before A. So let's just see. If I do negative of A, of course, in the ASCII table, there is a value given for that, and that is for the 64 number is for the @ symbol. I hope you have seen it. If you have not gone through the ASCII table, please search on any search engine, maybe Google ASCII code or ASCII set for ASCII set for 1 byte or maybe 2 bytes. Over there, you can find out the whole ASCII table, and you can find out that how that ASCII table is stored for each alphabet or each alpha number. From 0 to 127 was the first table that was stored for 7 bits over there, and that is storing over there. So the first step of this chapter is it that you can store a string inside double quotes by using either an array or either a pointer to a string which is stored inside the memory. Okay. Remember, there is no string data type. If I want to store it something like this without this static, this will be giving me an error. Of course, this will be giving me an error. This will never be running because you can see this is an error. Why? Because character is always a one character, one character, one alphanumeric or one alphanumeric character over there. But when I put this thing, it points to the first element of this string, which is I over there. And remember, by default, after E, when this is going to be stored over there, there will going to be a null terminator. So this will be having a null terminator. Null terminator will be always at the end of this string, which is actually \0 over there. So you already have this idea. Now, coming to the next thing, I want to use this function, which you have just seen just now over there. This was this alphanumeric over there. Now, for that purpose, I can change this code over there. I can, in fact, let me just use this code over there. So if I have this thing, let's say if I have to add, remember, I have to add the Ctype, Ctype.h over there, and just save it. So now over here, which function are? Now, Visual Studio Code gives you this option. Now, since you can't remember every function, as soon as I will write down is, this will give me all the options which are starting with is. And you can scroll through this all, and you can see over there is alphanumeric, there is alphabet, is ASCII, then there is blank, then there is a control character. I will just show you on the slides what are these control characters, or is digit, is graph. Graph means that it's printable over something, is a hexadecimal number, is ideogram. Now this is something different. It's not available for your actually this chapter number 8, but it's also there. Is lower, which means it's a lower case letter, lower alphabet I'm talking about. Is a number, which means it's just a number from 0 to 9. Is a phonogram, is printable character, is a punctuation marks, is a rune, is a space over there, is a special character, is an upper digit over there, or is X digit. X digit means here for the hexadecimal over there. So you have a lot amount of options over there. Let's say I want to first of all use this is element. I'm not going to go all through of them over there because it's going to be time taking. I want you to actually go through this. So when I have this function, and inside this function, let's say I have the C given. And what is C? C is a character which I am giving as A. And here inside this wing, I am going to print F over there, and inside it, I'm going to write down, yes, character C is an alphabet. And then afterwards, backslash n, just to give my, and afterwards, the semicolon. So what it's going to do, it's going to check is alphanumeric, which means that this character C, whatever is stored inside it, yes, character C is an alphabet. And if it is not there, else, then inside the parenthesis, I can write down and just copy this statement over there. No, character C is not an alphabet. So you have it over there. Now let's just run it and see what is the answer. Now what will be the answer? Now it's a very tricky thing because C over here is A, and here before this statement runs of if else, I have done C minus minus. So this is now going to be as that at symbol. So this means that this statement that is yes, character C is an alphabet is not going to run. So let's see what happens. So when I just do this one, I guess I have done some wrong. I guess I have print. Oh, sorry. Again, I selected and that thing is working. So when I run it, you can see no, character C is not an alphabet. So over here, let's say I have this as plus plus now. So now I'm making C character to be now A plus plus, which means it's going to be B. So it's going to be yes, character C is an alphabet. So you can see now that this function is AL alphabet or alphanumeric. So this actually tells over there. Now, if I have a character, let's say if I have a character, let's say I have character B equal to, and inside it I store 0. And inside, instead of C, I put B over there. Now, since this is alphanumeric means an alphabet also and a numeric also. So this character C is an alphabet or numeric. Now, this is something is not an alphabet or numeric. So let's just see what happens when they run it. Yes, character C is an alphabet or numeric because this function does not only check it's an alphabet, it also checks it's a numeric. So character B is equal to 0 over there. Now let's just check one more thing. If I have an integer x equal to 0, okay, if I have an actor over there and inside it I pass this parameter of x. If I pass this parameter of x, will this give me an answer? This is the question over there. Let's see first of all what is the answer. Now when I run this one, it still goes on. Why? Because when I'm storing this as 0, this is no, it is not, because this 0 is not stored as something. This is stored as an integer inside it. It's not stored. So this always takes this alphabet or this C type. This is always going to take a character inside it over there. And if I go back on your slides over there, in fact, let me just go back on your slides. And for the slides over there, I've just gone through this C thing over there, the characters and how you are going to have it. The single quotes I used for the single digits over there. And for ASCII values, I told you capital A is for 65, B is having 66, and so on, so on. But here, this is a 0 stored in single quotes, then it is 48. If it's a space, then it is 32 over there. What is a string? I have already told you, you have to use the double quotes over there. I've just gone through this whole slide over there. You can go through this one yourself. A single character with using single quotes, a single string with one character using double quotes over there. And you already know that every string has to have a null terminator as shown over there. And this is continue past your. So if you are don't going to write down this null terminator, then it will continue to pass on and print on, because this null terminator actually tells the compiler that the string is finished. So if there is no null terminator added over there, which will be the possible case in our scenario at one time, then it will either print garbage or it will crash your program having a segmentation fault. So this is very important. But again, you don't have to add when you're declaring strings over there, just like our case over there. In this case, you don't need to tell the compiler is automatically going to add it. But whenever you are concatenating two strings, which you have done in your lab as well up till now, then in that case, then you have to add. We'll go through that function most probably in the part 2 over there. So you have to do that one. So this is very important. Then next thing, coming to the next slide, which is actually my case over there. So you can have a string by an array or by a pointer. Exactly the same thing. So this is a pointer to a string. Again, if you add the word const over there, then this is not modifiable, and it points to b in the blue, which is actually the first character inside your string over there. And here this is blue, which is stored inside the array. And when this is stored inside the array, this is blue, and of course the null terminator is added over there. You can also make this something like this, blue and \0, which is actually the null terminator, and the size of this is equal to 0, 1, 2, 3 over there. So the size is 3, but actually the last element 4 is for the null terminator whenever you are storing a string inside using this double quotes over there. Then same thing, a string is accessed by a pointer to its first character. I've already told you on this thing. So whenever you are storing it inside an array, this is an hello. So h is stored inside the first thing. This is actually going to be the first character inside your string array, or the character array. Actually over there, no, there is no concept of string array over there. It's a character array because each character is individually referenced over there. Then next thing, very important, whenever you are going to have reading this all over there. In fact, before this slide, I just want to go towards this slide, which is actually something very, very important. That is character testing functions, for which I have done the very first thing, that this is a alphanumeric. C is a letter or a digit. I've just done this one. Now you can do it for isdigit C. You can do it for isalphanumeric over there. You can do it for isxdigit C, the hexadecimal digit over there. For example, let's say I want to just do it isxdigit. So let's say I have over there, let me just add, just copy paste this thing. So I have another one. If, where is this statement? If x digit, let me just change it over there for you. If x digit, and inside it, I am putting C, because C inside it has A over there, and A is a hexadecimal digit. So yes, character C is a hexadecimal digit. And here is not a hexadecimal digit. Sorry, I'm already spelling. So if I just print it over there, and you can see now, I guess I have done some wrong again. I guess I have. So you can see no, character C is not an alphabet or numeric, which is actually for the first thing, which was this alphanumeric, the first thing. And then I have isxdigit C. This is telling me, yes, character C is a hexadecimal digit. Why? Because this is stored as A. Now, instead of C, A over there, let me just change it to, let's say, H. Now, H is not a hexadecimal number. Hexadecimal numbers only go from 0 to 9, or A to F, or small a to F. So when you are going to do this thing, and now this time it's going to print no, character C is not a hexadecimal digit. So I hope you are getting the point. What I'm trying to tell you, that these all libraries, isdigit, is alphanumeric, or is alpha, sorry, alphabet. This is alphabet. But if you want to do both of these two, then this is alphanumeric, is alnum C. Then there is isxdigit. Then there is lower, is upper, and all of these are going to take the character input inside the parenthesis. So it's actually a function added inside the Ctype.h library. So it's going to, now let's just see if I want to check on for this is lower and is upper over there. So if I want to check that one, is lower and is upper. So if I have to do this one as well. So let me just change, I guess, for this one. Let me just copy this one again, and let me just print it over here. Is lower or is, so is lower. Remember, when you write down automatically, so is lower. So yes, character C is a lower case alphabet. So is not a lowercase alphabet. So is lower C, and C is here H, and that is capital over there. So now what will happen? You can see now, no, character C is not a lowercase alphabet because I have used capital H. Now, just for the case of it, I change it to small h. Now you will see the third statement will change to something else. And now you can see, yes, character C is a lowercase alphabet because I have changed it to H over there. And remember, this is going to give you for A to Z only, not for anything else, because 0 to 9, they can't be in lowercase or uppercase. They're exactly the same thing over there. Then the last thing of this C character structure over there, that is the part one of this one, is that it is space over there. That is, C is a white space, space, tab, or new line. You can do this one also if this is a space, tab, or new line. I want you to try to this one over there. So all these functions, these take on and return a non-zero if condition is met, return 0 otherwise. So these are simple functions, and you can use these functions inside your printf statements or inside your if else statements. And these are available in Ctype.h library. Now coming to, and again, the same thing over there, coming to one thing which I missed over there, and I scroll down below. Whenever you are taking an input from the user, okay, whenever you are taking an input from the user and you are reading some strings over there and you want to store it inside a character array, over here is a character array, that is a word array and 19. Remember one thing, whatever the size of your array, make it one less and use it for s, which means it will read up to 19 characters and stored inside that character array as a string. Why? Because the last is going to be stored as a null terminator. Remember, don't miss the null terminator. If you write down 20s, the null terminator will not be, and there will be a segmentation fault. So it will remain 19s means percentage s simple means it's going to read the string. 19s means it's going to read maximum 19 characters, saves the last position for the null terminator, that is \0. Without the field width, user can overflow over there. Now, let's say if I want to just say I want to do something, I want to just make this run for you. Let's say I want to have a character array. Let's say I have h over there, character array, and sorry, I have to use the 20, and that is something like this. Scanf, brackets open, enter some words. And here beside it, percentage s, and instead of percentage s over there, let's see, I want to write down 10s over there, and here I have written again 10s. I'm just doing it deliberately so that it's something. And here I write down h over there. Now remember, when I write down h, I don't need to write down and over there. Why? Because it's an array. An array is already a pointer. I told you, you don't need to give it the add symbol over there. So when I will just run it, so you can see it, one not generated, a destination buffer. You can see now it's giving me an error. It's taking an input, but it's a warning generated because 10 and 10. So what this means, I will just break off this one chain over there, and let's just make it 9 over there, and now run it. Hopefully the error is not there. So now I enter some words over there. I hope so. It's taking me some input, and when I just print it, you can see now. So it's asking me enter some words inside it, and I'm writing down scanf over there, enter some words over there. So I'm putting it inside the h over there, and afterwards, let's say I want to add something inside it. You entered, and here this is going to be percentage s, and here inside I have the h over there. So when I will now just run it over there, so this is character is I, and afterwards, if I just put it something over there, let's say I am entering some text. Let's just see, I am entering some text. Now see, I am entering a lot amount of text. Only 9 has to be stored. But when I'm going to, I am entering some text for part 1 of strings and characters. When I press enter, it's not storing anything. Now, what's the reason of this thing? Think on it, one. What's the problem which we are doing over there? The problem is this, that I have not added anything over there. So it's going to store inside that word. And when I'm going to, the word is not going to be, so there is not going to be and, so that's not the reason over there. So what's the reason over there? That it is not printing anything. So scanf, enter some words, and they have percentage 9s over there, and it's storing inside the h over there, and you entered, and it's empty. Why? Because I have overflown that one. Let's say I run this program again, and I have now, let's say, I am Arsalan. Again, it's not printing anything. Think about it. What's the error over there? The error is there, which means that I'm putting something data. The scanf is there. So either this statement which I'm adding over there is the problem. Let's say I just don't want to have this statement. And if I again do it over there, and so I am Arsalan, and over there. Now you can see over there what is happening. I is printed. I is printed over there, which means this means that some of the text is being printed over there. So for that purpose, let's say this is 20 and I make it 19. And over here, again, let me just run it over there. And here I am Arsalan. Again, only I is being printed. Think on it. What's the error over there? There is something an error over there, and that error is actually making that thing not display over there. The error is there. Please think on it. Most probably write down in the comments what is the error over there. There is an error which I'm doing over there, and that because of that error, the scanf command is not reading the input, or in fact, if it is reading, it's not printing the whole line over there. It's not printing the whole array over there. What is that error over there? So if this is a string over there, so what is happening over there? So why only I is being printed? Think on it and answer me in the comments over there. I will leave this, maybe I will answer it in the part 2 over there for you. And I will leave this question. This is related to something with strings and character. I have just told you in part 1, what is the error over there? You have to answer me, what is that error over there? I will come back to this in the part 2 and on this slide over there. Next thing, very important, some fill in the questions. A string is accessed via a pointer to the string's first character. We already know that the answer is pointer. So nothing fancy over there. A string is accessed via a pointer. Next question, the following initializes color to blue. Yes, but there is something wrong. You don't have the null terminating character, and that is, you are missing this thing. You don't have the null terminator. So this is the false answer. You have to write down the null terminator also. Then the same thing, I've already told you about the Ctype.h test characters. Is it a digit, letter? It converts the character uppercase to lowercase or something like that. And the whole library is over here, is digit, is alpha numeric, is alpha numeric over there, is alphanumeric, and a number over there, is x digit, is hexadecimal digit, is lower, is upper, is space. So these are the more common ones used over there. Otherwise, if you want to go in the Visual Studio Code and find out all of them, they are also there. Then next thing, then there are some other functions as well, which are also there, which is control. You can use these ones over there. And C is a control character. Now, control characters are those with the backspace over there, which are with the backslash, which is T, tab, new line, carriage return, and is punctuation. Punctuations can also be there, which is the dollar sign, the hash mark, the exclamation mark, the question mark, or etc word. Now, these are punctuation marks. You can use this also. If is printable, which means it's a printable, including the space. Now, some of the things are not printable. For example, this is not printable, this is not printable, this is not printable. Yes, space is printable because this is an empty space, and that is having an ASCII character of 32, as I told you before. Then is a graph, which means it is printable excluding space. So these two are exactly the same thing, but just one is including the space, other one is not including the space. So this is the including the space, this is excluding the space, is print, and is graph. You can use this one in detail. Then is blank. Now, sometimes the user is not going to enter anything. So it's blank. So this means that C is going to be blank, space, or tab. So if you want to select, if your user has entered a space inside it, then you can use this one, or you can loop it through your array. Sorry about that. And C is blank, so it's a space or a tab over there, because user can enter from the keyboard a tab also and a space also. So you can easily do it. And for this purpose, I have an example already there in my chapter number 8 library. And over here you can see this library, this function or this code has everything. You can see this is a digit, this is an alpha bit, this is an alphanumeric over there. Then this is x digit for f. J is not going to be hexadecimal over there. You can run this code. I will just run this code in front of you. Sorry about that. Again, the bulb comes in between. And you can see over there, the all digits are there, and the printf statement is using everything over there. It's using %s for all these comments over there, and then the backslash n to make it into 4 different lines. You can go through this example. It's using all of these digits. And remember one thing, it's taking the ternary operator. This is a ternary operator, the one which I've highlighted over there. This is the function. If it returns true, then this is printed. If it is returning false, then this is. And the both statements are 8 is a and 8 is not a. So this is not and the agreeing statement over there. So it's exactly the same thing. You can use an if else statement also, but this is a better way of using it by using just one line, which is also called as the ternary operator. This is the question mark. If it is true, then this is given the answer. If it is not true, then it is, and it is using this one and this one over there. So this is a very simple example. You can go through this one yourself and you can go through the results over there. Then you can convert it into your lower, or you can check it over there. If it is a lower, it is an upper over there. Again, using the ternary operator over there. Again, the answer is going to be is a or is not a. So it's exactly the same thing, is nor over there. And if you want to convert it into an upper, now this is something different. This is not going to be a if and else statement. This is going to be just a function. So this is converting into two upper, and in brackets you are giving a character. Again, this is a character, so it's going to go into single quotes over there. So it's going to be U, and it's going to, when you are going to run this code, let's see if you run this code. So U is converted to capital U, 7 is converted, it's not going to be changed because 7 is 7, either uppercase or lowercase. Dollar is also just a symbol, it's just like a symbol, so it's not going to be changed. Capital L is going to be converted to lower. So using the function lower to lower, it's going to be changed to smaller L, which is shown over there. Then next example, from this example, you can go through this one yourself and over there. And this is exactly the same thing. If you are trying to find out is space. Now is space over there. If you are trying to find out is this is a space. No, this is of course not a space. So if you are going to run this thing, again, the same bulb comes in over there. And if I run this one, you can see over there, according to is space, new line is a white space character, horizontal tab is a white space character. This is not a white space character. And you can see everything is written over there. So it's just a way of presenting your case over there. This is the first printf statement over which I've highlighted. This is the second printf statement which I've highlighted, and this is the third, and subsequently this is the fourth and fifth over there. So you can have all of these functions, and which are these functions over there. You can see is four functions are being used: is space, is control, is punctuation. You can see the punctuation. This is a punctuation. This is not a punctuation. This is a punctuation character. Now, normally in English, we don't use hash mark as a punctuation character, but here in C language, they have taken the hash mark as a punctuation character. Of course, in English language or English literature, we always use question mark or maybe comma or semicolon or colon only as the punctuation. But here, the hash mark is also taken as a punctuation. Is printable. Of course, this is going to be printable. But if you use \A, alert is not a printing character. It actually makes the computer uh, beep go on, which is certainly not going to go on in my case or your case, because the Windows is not going to allow that. And then there is graph over there. The Q is a printing character other than the space. Space is not a printing character other than a space. So these are small 3 or 4 functions over there. You can use these ones over there to find out that the number or the character. Again, remember, these are the character which are going to be evaluated over there in each of these examples over there. Next example, I guess we'll be discussing this one in the part 2 over there. But before that, before I go on and complete this part, I guess this was the same example being discussed over there. So you can go through this example, and I would like you to write down these examples yourself. Instead of just going through them, please use all of these one for any code we write down, and use all of these character conversion functions, especially this one to uppercase and to lowercase over there inside your strings over there, and use all these case conversion. The same example, I've done this one in your Visual Studio Code just now. And then go through this example, which is a password validation, which is something very, very important. Whenever you are going to have a password entered from the user over there, just like this one, you can have the password entered over here, and you are having again 19s over there, and the password being stored inside whatever is being entered. And now inside a for loop, which is going from 0 till the last null terminating character. So what is going to happen? You are going to check on that each character inside that array is equal to, so has digit is equal to 1. If is digit is not there or there, that these three things are going to be changed. Otherwise, has digit 0, has upper 0, has 0. So these three are the three attributes you want to check in your password. So if it has digits, which means 0 to 9, if it has uppercase 0 to 9, so 0. If had 0 lower also, which means A to Z, smaller letters over there. So these three if else statements, they are just in one line, so don't worry on that part. It's, you can make it in 2, 3 lines over there, totally up to you. So if these three conditions are met, then at the end, if it has digits, it has an upper, it has a lower, which means all these three are 1111, which means that the password entered by the user, the 19-digit password, 20th is the remember the null terminator, then it's going to print it's a strong password. Otherwise, it's going to print weak, need digits, uppercase and lowercase, and you can make it back on the enter password again using the while loop. In fact, this will be a very good assignment for you. Change this code which is right in front of you to ask the user to again and again enter the password using the do while loop, and check inside the while loop if the password and everything is okay according to your limitations, and add another limitation of adding a punctuation mark inside your password. So in this password, you have a digit, you have a upper, you have a lower. Add for the punctuation marks and also add that how many digits should be there inside your password. This is a very good assignment to use all of this. And for that purpose, you have to change something inside this for loop and add some more variables, which will count that how many digits you are adding, which means how many 0 to 9 digits you are adding inside it. When you are going to go through this for loop, which is going to go through all of those passwords over there, after every time, this loop is going to run for those 20 or 19 times actually over there. In fact, 20 times, because this is going to be, it's asking for the null terminator. So please go through this one. I have asked you in this part one to change this password validation code according to the requirements I have told you. And that slide which I've asked you, that why that slide was not, or where that code was not working, and it was not printing the whole string which I was entering inside that array over there. Then last thing, I guess, before I close this part one, because I don't want big parts over there, so that are very small ones and you can easily go through them. Which function is returns true if the character is a digit or a letter? So this means you want to actually have both of them. So I guess this is going to be is alpha numeric, which means AL over there. I guess the answer is already there, is AL You can easily get it on over there. These are all 12 questions which are inside your book also. So I'm not going to go inside them. The next question over there, what does this print? Printf %s \n is alpha, and this one. So this means this is a ternary operator. So this is a function. M is a letter, M is not. Now here, as you can see easily, M is of course a letter. So what is going to printing? M is a letter is going to be printed over there. You can see the M is a letter. So instead, this %s, this thing is going to be evaluated, and M is a letter is going to be, because in this function, M is of course a letter alphabet. So that's why M is a letter is going to be printed over there. Then next thing, I will come back to this in std library of H in part 2 over there. I hope you can go through all of these ones, and do write down in the end of this comment over there on this video that what is the problem, that why this function, when I'm taking an input from the character over there, is remembered over there. So when I'm writing down something, let's say I am adding over there, now it takes on the input, but I'm taking the over there, why it's not giving me an output over there. So give me an answer, why is this a problem? I will see you in part 2 again. Thank you.